All right, so they're telling us here, it says find xf if xa is 7x minus 1, xf equals 10x. So the, actually talking about just two segments here, right? xa and xf. I think it's a good idea to just visualize which parts they're giving us. So there's xa, and then that's xf, right? Now, what ratio are we going to use? If those are the parts that they give us.
1/3. 2/3 ratio.
2/3. Okay. The red part from the vertex to the centroid, that's always the larger portion of the median. So that's always going to get the 2/3 thing, or a ratio. Somebody in the last class said, because we're having the same issues of where do I put the 2/3 on what side, and somebody said, well, what I've been doing is just writing it out in words. And they said, I write XA is 2/3 of the median, which is XF. So they write it out that way. Okay? And this is a great idea because, and this is what I was trying to teach you guys to kind of think of maybe in your head, not necessarily write it down. But if we write that down like that, do you guys remember back to Algebra 1, like the first 2 weeks of Algebra 1, you'd get an English statement in words, and then you had to convert it over into algebraic expressions or equations? That's what they were doing. And they're saying, okay, how can I apply the geometric theorem using some of our algebra? XA, what symbol is? What does is mean? Say again? Equal, right? Okay. Is something. You are, or you is a sophomore, right? Means you equal sophomore. You're one of those things, okay? So XA is, now it says 2/3 of, okay? What does the word of mean algebraically?
Multiplication.
Multiplication. So we get 2/3 times XF. And it tells us then what side the 2/3 has to go on, okay? There's other things to do, at least in this context, that could remind you where the 2/3 goes. 2/3 or the 1/3 ratio always shows up on the median side. So of XA and XF, XF is the median, right? So 2/3 has to show up on that side. But I think this is a great skill to have because there's going to be other things, other ratios and other properties, theorems that we talk about throughout the rest of the year and in other courses where it's a good idea to be able to take those English phrases and convert them over to algebraic equations or expressions. Where kind of the shortcut of saying that 2/3 always goes on the median. Well, what if we're not talking about medians anymore? Does that make sense? So now it's just a matter of whether you want to plug in now, that is 7x minus 1, leave your 2/3, and then plug in 10x. Okay? I would probably, and I'm not saying I'm going to do it the right way or the way that you would do it, but I know when I distribute that 2/3 to 10, or just multiply those together, that's 20/3. That's really not a nice number. But it's just options. I guess you can multiply that through. You can multiply both sides by 3 right away and get 3 times 7x minus 1 equals now 2 times 10x. Okay, that's nice because you got rid of fractions, right? Okay. Some of you might have been, well, I do that beforehand. I come up here. Okay, could I do the algebra of multiplying both sides by 3 right there? And multiply both sides by 3, you get 3xa's is equal to 2x's. Okay? Where if we look at this expression here, the xa is equal to 2/3 xf, the logic there, the thinking that we're going through is that we want to take the blue segment, which is xf, multiply it by a number between 0 and 1, so it's going to shrink it. And it's going to shrink it so that that blue segment is exactly the same size as the red one, right? If I look at the statement where we said 3xa is equal to 2xf's, what that is doing, kind of conceptually, is saying we're going to take 2 blue ones, and we're going to take those 2 blue ones and we're going to stack them end to end. And then that should give me, or equate to, three of these red ones stacked end to end, right? Does that kind of make sense? Okay. So when you multiply both sides by 3, you're now saying, okay, now we're going to look at those two segments individually, but multiples of those two segments individually. See how many of one is going to equate to how many of the other. Okay. Either way you want to look at it is fine. But when we multiply that through, I'm going to get, what, 21x minus 3. 21x minus 3 is equal to 20x. Move my 21x over, so it gives me negative 3 is equal to negative x. X then becomes 3. Okay? You would end up with the exact same result regardless of the algebra that you go through. As long as your algebra doesn't violate any rules, you should get 3. So then the next question is, or the next part, I guess, is they want you to find xf. So xf is the 10x. So 10 times 3 is 30. I think the biggest thing that we're seeing and we're running into, and you heard me say this before, is where does that 2/3 go? Okay, does it go on this side or does it go on that side? Okay, and being able to write it like this is going to be able to be, I think, maybe a lifesaver on some of these questions for some of you guys. Okay, so they're giving us GV, right? Talking about GV is what we're looking for, but the components they provide me are RG and RV, right? So those are the objects they give me. So those are the only ones I can use, right? Even though I talk about GV, I only have expressions for the red and the blue, right? Okay, so RG is the smaller segment, right? So what portion is RG going to be of the red one? What ratio are we looking at here? 2/3. So we're going to say RG is 2/3 of what? The blue one's 2/3 of RV. 2/3 of the red one. Good. Okay. So now if I convert that into algebra, RG is 2/3 of RV. Okay. Just maybe creating some easier algebra here. Let's go ahead and multiply both sides by 3 right here. If I multiply both sides by 3, that's going to give me 3 RGs is equal to 2 RVs, right? So now I have 3, 5x minus 2s is equal to 2, 6x's. So it gives me 12x, 15x minus 6. Subtract my 15x from both sides, and it gives me x to be 2, right? Now, the question is, what is G to V? Okay? Well, VR is 6x. So V to R is 12, right? G to R is going to be 8, isn't it? So they want G to V. They want this remaining green portion right there. So what's that got to be?
4.
It's got to be 4. And we could check ourselves. If I check myself, plugging that, I get 4. 4 compared to 8 is 1 to 2, right? 4 compared to 12 is 1 to 3, right? 8 compared to 12 is 2 to 3. So all those ratios that we know should exist do exist. I got some people earlier today and yesterday saying, with that stuff that I just circled, let's say they go through the math and they get 2 and they come back up here and said, I got 2, and I know it's right because I plugged it back into my equations. And my equation on the left-hand side said I got the same thing I got on my right-hand side. Well, if you do that, that's fine, but that's only checking your algebra. Okay? So if you set up, instead of 3 RGs equals 2 RVs, maybe you said 5 RGs equals 13 RVs, and you can go through the algebra and solve that, and you plug things back into your equation, you're fine. You see that your algebra for your equation is correct. But the equation that you make does not relate to the geometry. Does that make sense? Okay? So when you check yourself, make sure that you are plugging back in or checking the overall problem, not just, kind of individual components. All right? So we gotta check the geometry, not necessarily just the algebra. Does that help? Stuff.